Welcome to this YSL tutorial. In this video, we're going to look at using for next loops in Excel VBA. We'll begin the video with a look at the basic syntax of the for next statement and how you use loop counters to specify how many times you want your loop to run. We'll have a quick look at the step keyword so that you can control how your loop counter is incremented or decremented, and then we'll also show you how you can prematurely exit from a for next loop in case you need to. The final part of the video will look at a few practical examples of using for next loops to loop through the items in a collection. So we'll have a look at how you can process a Worksheets collection, Workbooks, and also a collection of cells. So let's get started. In VBA, a for next loop allows you to take a set of instructions and repeat them a number of times. Here's the basics of how they work. First of all, we'll need a variable which allows us to count through our loop. I'm going to declare one called loop counter, which is a nice obvious name, and it's going to be as an integer. Often in the real world you'll find people call these loop counter variables simple things like I for integer or n for number, but I prefer the slightly more descriptive names, so I'm going to call mine loop counter. What we then need to do is tell our loop to begin and what range of numbers it should count over, and we do that by writing the word for, then the name of your variable, in this case loop counter, and we make it equal to the range of numbers. So we say where it begins, I'm going to start at the number 1, and then we say where it ends, I'm going to say to 10. So that means my loop will count 10 times. Hit enter a couple of times, and then to end the loop later on, or at least to go on to the next iteration of the loop, what we write is the word next. And that's actually sufficient for this to work. We don't need to specify anything else. However, I always find it useful to say after the word next, which next thing we're moving on to. So all you need to do is use the name of your variable again at that stage. So that is a loop that will run 10 times. So to prove that that happens, we simply need to put some sort of instructions in between for and next. We're going to do something very, very simple. It's not going to be useful at all, other than to demonstrate that the loop is working. We're going to use the debug.print statement, which will list some information into the immediate window. And what I'd like to debug.print is a little message which says loop counter is equal to, and then the actual value of the loop counter variable. Okay, so in order to be able to see some results, I'll need to view the immediate window from the view menu. And then if I start stepping through this routine using the F8 key, we should see, as soon as I enter my loop, loop counter becomes 1, or whatever you set the starting value to be. And it will then continue to step through and, of course, print out the information into the immediate window. When we reach next loop counter, that will automatically increment the value of the counter variable by 1, so that it becomes 2, unsurprisingly. And that carries on happening until we reach the end of the loop. So we'll get to the value of loop counter as is the number 10, if we can see that. The next loop counter statement will execute again, which will increment the value of the loop counter to 11, as it turns out. But it doesn't re-enter the loop and iterate through again. So once the loop counter has exceeded the limit we set here, the subroutine continues with the rest of the instructions. So that's the very, very basics of how for next loops work. There are a couple of ways you can modify the way the loop counter itself works. So let's say, for instance, that we wanted to go from 1 to 10, but we didn't want to increment by 1 each time. We wanted to go up by 2. There's a little modifier you can make to the for statement using the step keyword. If I say step 2, that means that the loop will count up by 2 each time I go through. So if I just clear out the immediate window quickly so we can see this happening, and use the F8 key to step through. So the loop counter will begin at 1 again, of course, and it prints out 1, but the next time we go to the next statement, it will add 2 to the loop counter instead, so it goes up to 3. And that will continue to happen. We'll get to 9, and the next time we increment the loop counter, it's going to go up to 11, and that will exceed the upper limit of the loop counter, so it will step out of the loop again, and then continue with the rest of the subroutine. We can also use the step keyword to reverse the way that the loop counts. So rather than going from 1 to 10, we could tell the loop counter to go from 10 to 1, and then to step -1. So that will decrement the loop counter by 1 each time we go through. If I clear out the immediate window again, and then fairly unsurprisingly, if I use the F8 key to step through, loop counter begins at 10, and then when we get to next loop counter, it will decrement that value, and that will continue to go through until we reach loop counter equals 1. This will decrement the value of loop counter again, so it will end up at 0. but because 0 is less than the lower limit of our loop counter, we end up out of the loop and then ending the subroutine. Sometimes you may want to end your loop before it's finished processing the entire range of numbers you've specified. So for instance, if you've generated some kind of error or you've satisfied some other criteria that means you don't need to carry on with your loop. And you can do that using the exit for statement. So let's see, just to demonstrate how that might work, we'll come up with a very simple example. We'll generate a random number within our loop, and we're going to store that as a double. And then inside the loop, we can store that value by using the rand function, or rnd function. So we're going to say random number equals math.rnd, which generates a random number between 0 and 1. Then what we could do is we could test if our random number is greater than, let's say, 0.7 for the sake of argument. Then I want to exit from my loop. And I do that with the exit for statement. So this is fairly hopeless as a practical example, I guess, other than to demonstrate how you can exit from a loop based on a condition. But if we begin to step through, we'll generate a random number, which in this case is 0.01, so that's not greater than 0.7. So we'll process the loop, and we get the loop counter of 10. We'll go through again and generate a new random number. This time the value is 0.76, so that is greater than 0.7, so this time the loop will exit, so that jumps to the next statement after next loop counter. So it's a quite neat little demonstration of how the exit for statement works. There are far more practical examples in the real world of why you might want to do this. This was just for the sake of demonstration. We use such a simplistic example. Okay, so now that we've seen the fairly boring technical explanation of how a for next loop works, let's look at a couple of practical examples why you might want to use this in the real world. One fairly common example of using for next loops is to process all of the objects in a particular collection. So what we're going to do as a demonstration is show you how you can process the worksheets collection, processing each individual worksheet object one by one. So we'll write a new subroutine, and what we're going to do to our worksheets, we'll protect each worksheet in turn. So I'm going to say protect all worksheets as the name of my subroutine. We know that we need a loop counter variable, so let's declare that immediately, loop counter as integer. And I'm also going to have a second variable, which is going to store the number of worksheets that I'm going to process. It's going to say dim number of worksheets as integer. What I can then do is store the number of worksheets in the variable that I've just declared by saying number of worksheets equals, and then I need to refer to the worksheets collection and then refer to the count property. Now nearly every single collection in VBA, in fact I'm pretty sure every single collection in VBA has a count property which tells you exactly how many items there are in that specific collection. So in this case the count of my worksheets collection will be 3 because there are 3 sheets. If I've got that value stored in a variable, what that means is that I can write my for next loop to say for loop counter equals 1, 2, number of worksheets. So you can use variables to replace the hard-coded numbers that form the start and the end of your for next loops. Give myself a couple of blank lines and say next loop counter, just as previously. And then all I need to do is inside, in between the for and next lines, I need to work out how to apply the protect method to each worksheet. Now this technique relies on the fact that one way you can refer to an object in a collection rather than by name. So for instance, one common way is to say worksheets sheet 1 and then do something to it, but rather than using the actual name as a string, you can use the index number of an item, and you see that in the little tooltip that pops up. So for instance, if I said worksheets1.protect, that would protect the first worksheet in the collection. Worksheets are indexed from left to right, just so you're aware. If I switch back to Excel quickly, worksheets are indexed from left to right. So in this case, sheet 1 will be number 1, sheet 2 will be number 2, and sheet 3 will be number 3. But that can change, of course, if you change the order of your worksheets. Anyway, back to the VB editor. Rather than using the number 1, of course, we don't want to always just protect worksheet number 1. We want to protect whichever worksheet whose index number is stored in our loop counter variable. So I can replace number 1 with the value of the loop counter variable, and that will protect each worksheet in turn. So if I use the F8 key to start stepping through, we'll find that we store the number 3 in the number of worksheets variable. Loop counter will begin at 1, so this is going to protect the first worksheet. As soon as I execute that line, the first worksheet is protected. And in fact, if I switch back to Excel quickly, just to prove that's the case, if I try to start typing into that sheet, you'll see that I get the standard error message that you can't because that worksheet's protected. If I just quickly switch on to sheet 2 for the moment, just to prove that I can currently type things into sheet 2, and then switch back to my code, and then begin using, carry on using the F8 key to step through. Loop counter is now 2, so this will be protecting sheet 2. Once that's done, if I switch back to Excel again, as soon as I start typing in, I'm told that I can't because that worksheet is protected. Back to the VB editor, I'll just carry on through with the rest of the loop using the F8 key, so that will protect worksheet number 3, and that means that I've now run out of sheets, so I'm going to exceed the number of worksheets variable, which means it passes out of the for next loop and then ends the subroutine. I suppose that I should write another quick subroutine which will unprotect all my sheets as well quickly, rather than having to do it manually. So I'm going to cheat completely here by copying the entire subroutine I've just written, pasting it in, giving it a new name, unsurprisingly unprotect all worksheets, and then I just simply need to modify the method that I'm using from protect to unprotect. And again, if I use F8 to begin stepping through, it'll go through once, twice, 3 times, and then end the subroutine. So I should now find that if I go back to Excel, I can now start changing things. I can delete content of cells and type in new things as well. And that's true for all of my sheets. Good. You can use this technique to process pretty much any collection you want in Excel VBA. So let's do another example where we process the collection of workbooks, just to show you how similar the technique is. We'll have another subroutine, which will be called, let's see, close all but this workbook, which hopefully is a fairly obvious descriptive name and explains what this subroutine is going to do. We're going to process the collection of workbooks, and we are going to close down each one except for the one in which our code is running, Top Movies 2012. So just like last time, we needed a loop counter variable, so dim loop counter as integer, and we're going to have another variable which counts the number of number of books this time. So I'm going to call this number of books as integer, and we can store the number of books just like we did with the worksheets.count. The workbooks collection also has a count property, which tells you how many items there are. Currently, there's only one item in the collection at the moment. We're going to insert some new workbooks just to prove that this one works. Okay, so we need then to start our loop for loop counter equals. Now this time, I'm not going to process my loop in ascending order from 1 to the number of workbooks. I'm going to go from the number of workbooks to the number 2, not 1, to the number 2, and I'm going to step minus 1. And I'll explain why I'm doing all that in just a second. A few blank lines next to the loop counter, and then inside the loop, I simply need to work out how to close down a workbook. And just like we did with the worksheets, I can refer to an item in the workbooks collection, rather than by using its name, I can use its index number. And the index number is stored in the loop counter variable again, and then I want to apply the close method to that object. Okay, so if I quickly switch back into Excel and create a few new workbooks, quickest way to do that is to hold down the Control key, CTRL, and press N for new on your keyboard. So there we go, we've got a few new workbooks up to book 5 at this point. Back to the VB editor, and then I can begin stepping through this subroutine using the F8 key. Okay, so I find that I've got a number of workbooks which is equal to the number 5 at this point, and hopefully we can see all those in the list. So I've got Top Movies, and then 2, 3, 4, and 5. So the first workbook that should be closed down, loop counter begins at 5, so it should close down workbook number 5. There it is, it's gone. So then loop counter comes down to number 4, that should close down the 4th workbook that I've opened. That's true. And then 3, and then 2, and then workbooks number 1 is the one that I'm currently working in. So that's Top Movies 2012. And this is the reason that I only went down to the number 2, because I don't want to close down that workbook, or this workbook in fact. So the loop counter will move on, but because I've said the lower limit will be the number 2, it won't actually close down this workbook. So there we go. I also want to explain the reason that I've gone in descending order as well, if that's okay. What I want to do is just quickly modify this so that we go from 2 to number of books. Then I'm going to switch back into Excel and insert a few new workbooks with Control and N. Let's insert 3 or 4. Then back into the Visual Basic Editor. Okay, so you can see I've got books 6, 7, 8 and 9 at this point. So Top Movies 2012 is still Workbooks 1. This is Workbooks 2, Workbooks 3, 4 and 5. So as I step through the routine, we'll find that number of books is again 5 because there are 5 open workbooks. Then I've said to go from loop counter equals 2 to number of books. So the second workbook is book 6 in this case. And that's going to close down book 6, and you'll see that one disappear. Okay. Then loop counter moves on to 3. Now, if workbook 6 had still been open, book 7 would be number 3. But because workbook 6 has been closed down, that re-indexes the collection. So now book 7 is currently workbooks number 2, which means that we're going to skip over book 7 and close down book 8 instead, which is horrendously confusing. And then next loop counter will move on to number 4, but I don't actually have 4 workbooks open anymore. I've only got 3. So I've got workbooks 1, workbooks 2, and workbooks 3. So this line will fail because there isn't an item to close down at all. That item doesn't exist anymore. So I'm going to end the subroutine at that point, but that was just why I went in reverse order from number of books to 2 with a step minus 1. So I just wanted to make sure that that was clear why I did that. Okay, so let's do one more example before we end the video. We've processed worksheets, we've processed workbooks. One other common example of a collection you might want to process is a collection of cells. So just switching back to Excel, what we'd like to do is process this list of films, essentially everything from cell A3 to A15, but I want to make sure that it would work if we had a longer list of films as well. It would still process that entire list. So, back to the Visual Basic Editor, I'm going to write another new subroutine called sub. We're going to rate all films. And we'll need a couple of variables to do that. I'm going to have dim loop counter. This time I'm not going to make it an integer, however. I'm going to make it a long, as in a long integer. The reason I'm doing that is that the integer data type has an upper limit of 32,767. It's fairly unlikely you'll have more than that number of worksheets or workbooks open, but it is quite possible you'll be looping over more than 32,767 cells. So the long data type has an upper limit of 2.147 billion or so. So that's more than enough to hold the number of cells we want to loop over, I suspect. So we've got a loop counter. We'll also have a dim number of cells, as we've seen a couple of times already, as a long. And then I want to store the number of cells in that variable. I want to make sure I'm on the correct worksheet as well, of course. So let's say worksheets sheet1.activate to make sure I'm in the correct place. Then I can say number of cells equals range A3, so that's the top of my list. I can find the bottom of my list by saying range A2 dot end XL down, and then I can simply say dot count, so that counts the number of cells in that range. Now I can begin my loop, so I can say for loop counter equals 1 to number of cells, a couple of blank lines, say next loop counter, and then I can work out what I actually want to do to my films. What I'd like to do to my films is work out a rating based on its length. So I'd like to pick up the film's running time in minutes, store that in a variable, work out if it's short, medium or long, and then put that value into column E for that particular film. The way I'm going to do that is I'm going to have a fixed point here of, say, cell A2. And I know that if I offset 1 row down and 3 columns across, that gives me the length, and 4 columns across is where I can put the rating. So if I have my loop counter, which will allow me to offset 1 row, 2 rows, 3 rows down each time, that will let this work. So back to the VB editor, I'm going to have a couple of new variables. We've seen this done a couple of times in previous videos actually. I'm going to have dim film length as integer and dim film rating as string. So this is going to store the words short, medium or long. What I need to do then inside my loop is I need to retrieve or store the film's length in the film length variable by saying it's equal to range A2, we know that's a fixed starting point, dot offset. The number of rows down that I would like to reference from there is stored in the loop counter variable. The number of columns across, as I said, was 3, and then I want to pick up the value of that cell. A quick if statement then, so let's say if film length, we've done this a couple of times already of course in previous videos, if it's less than 100 then film rating equals short. You're probably bored of seeing this happen at this point, aren't we? Else if film length is less than 150 then film rating, it's so quick I can type it without even looking, equals medium, else film rating equals long. Now that I've got the film rating with an, if I end the if, now that I've got the film rating stored, I can place that in the cell that is offset. Let's just quickly cheat. So range A2.offset loop counter, comma 4.value equals film rating. And that's it. That will move on to the next loop counter, and that will process all of the films. So let's just change the screen width so we can see what's going on here in the background. So if I begin using F8 to step through, we'll select worksheet 1, pick up the number of cells, which is 13 in this case. If I have more films, that would be a bigger number, of course. So I'll start at the number 1, and I'm going to pick up the film length from the value of the cell 1 row down, 3 columns across. That stores a value 143, which is the running time in minutes of The Avengers. Work out that that's a medium film using the if statement, and then pass that into the value of the cell 4 columns to the right. And that's where it goes. If I carry on stepping through, we'll see that the loop count goes up to 2, so this time I'm picking up the value of the cell that's 2 rows down, 3 columns across, and you probably get the idea at this point. If I could quickly switch back. So all I'm going to do now is just hit the F5 key to process the rest of the loop quickly. So press F5, and that's the entire subroutine finished. So there's another example of using a loop counter, a for next loop, to process a collection of objects. That's the end of the video. Hope you found it useful. Thanks for watching. If you've enjoyed this training video, you can find many more online training resources at www.wiseowl.co.uk.